Hello and welcome to my science tutorials, and in today's video we are going to look at organic chemistry. Yes, an introduction, a basic introduction to what organic chemistry is. So so let's get started. So what is an organic chemistry? So an organic chemistry is the study of chemistry of carbons and hydrogen, including other heteroatoms such as nitrogen, sulfur, oxygen, and halogens. The halogens in this case include chlorine, bromine, and iodine. So the study of any the study of the chemistry of compounds containing carbon and hydrogen, and then other heteroatoms like the nitrogen, sulfur, oxygen, and the halogens can be defined or can be termed organic chemistry. Now organic compounds are classified into 4 groups. Okay, so depending on the structure of the compound, things attached to it, the number of double bonds, then and other things, whether it is straight, branched, or cyclic or not cyclic, then we tend to classify organic compounds differently. So the first example we want to look at over here is the aliphatic hydrocarbons. So we have over here the aliphatic hydrocarbons. So the aliphatic hydrocarbons, they include alkanes, alkenes, and alkynes. So what are they? They are carbon compounds arranged in open chains. So they can be in open chains, can be straight or branched. They may contain single or multiple bonds. Multiple bonds include double and triple bonds, and etc. So what do we mean by they can be straight or branched? So let's have a look at something over here. So what we mean by they can be straight is, you see an organic compound like C, then another carbon, then you have just hydrogens attached to it like this. Okay, so something like this is what we termed a straight, like it's a straight chain, there's no curve, no nothing anywhere. Okay, so this is a typical example of a straight chain alkane. Okay, so with that, let's have a look at what we mean by multiple bonds in aliphatic hydrocarbons. So multiple bonds include double or triple bonds. Okay, so we have carbon double bond C or carbon triple bond C. Now whenever we have a carbon double bond C, they are called alkanes. Okay, carbon triple bond C, they are alkynes. Okay, we need to take notice of this. Now the carbon single bond carbon, which is the alkanes, are said to be what? Saturated compounds. What do we mean by saturated? Now the bond between these two carbons is a sigma bond, which is very strong. Okay, the electrons between this bond, they are not delocalized, which means they don't move, they are just at a fixed point. So they are just at the middle there, they don't move to the C over here or the C over here, so they are just still there. So they are not delocalized, so they are localized. It means they have a location, you can find them. If it is the middle, it's the middle. If it is slightly towards the left, it's slightly towards the left, but they will not move. Okay, now for the multiple bonds, which include the carbon-carbon double bond or the carbon-carbon triple bonds, they are said to be what? Unsaturated, which means they have delocalized electrons. Now the delocalized electrons is as a result of the pi bonds that they have. Now the carbon-carbon double bond over here has one pi bond over here, so one is sigma, one is pi. So the pi bonds, the electrons over there are delocalized, which means they are easy, like they can move around. So at a point in time you see them very close to this carbon, another point in time you see them over here, so they are moving all around. The same thing with the alkynes. So alkynes, they have 2 pi bonds and then 1 sigma bond, and then the pi bonds, they have their electrons delocalized. And so that is what we mean by the 2 terms over here, the saturated and then the unsaturated hydrocarbons or compounds. Now the second group of organic compounds is alicyclic compounds. Now you can see maybe in an organic textbook you see something like this, okay, or something like this. please never in your life as a science student or a scientist say this is a square or this is a triangle, because it is not. In organic chemistry, this is cyclopropane and this is cyclopentane. Okay, and then when we have this one having a double bond, when it has a double bond, then this change to cyclopentene. Okay, we will look at the naming of these compounds shortly, so you can get to appreciate what we mean. So let's move on now. The third class yes, of compounds, they are the heterocyclic compounds. So these heterocyclic compounds, they are compounds with rings. Okay, they have rings, and then they include other atoms apart from what? Carbon. So if we have, let's say, a ring, okay, and you have oxygen here, something like this. Now at every point over here of the ring we have carbon. So here we have C, carbon here, carbon here. Now because we have a heteroatom, which is the oxygen over here, this compound will cease to be what? Alicyclic compound, and become what? Heterocyclic, because of the oxygen over here. So compounds like this that are ring, and then they have another carbon, another atom forming the parent chain aside carbon, they can be considered as heterocyclic compounds. Now what are aromatic compounds? Now aromatic compounds are closed rings of carbon atoms with pi electrons delocalized across their surface structure. They can also contain other atoms like oxygen and nitrogen. They are popularly known as the benzene compounds. Okay, now for it to be aromatic, there are a lot of criteria you need to meet, so we will not look at that in this video. But then the popular aromatic compound that we all know is the benzene, which is a 6-membered ring with 4 degrees of unsaturation, which is 3 double bonds. So now you see this is a double bond, and these double bonds are what? Unsaturated, which means the electrons are delocalized, which means at a point in time you see this bond over here, this bond here, this bond here. Another point in time you see this bond over here. So what do I mean by this? Let me draw the resonance structure. So at another point in time this bond will be here, then this one will move to the next side, and then the other one will move. Okay, so this way of rotating is to stabilize the ring. So because the electrons are delocalized, they are not fixed, so they are just moving around. So we draw a resonance structure which is like this, and then we just put circle inside to show that the electrons are actually moving within the ring. So yes, this is a typical example of an aromatic compound. So let's have a look at other terminologies in this example. So what is a hydrocarbon? Now any compound at all in this world that contains only carbon and hydrogen is a hydrocarbon. Very simple. So from the name hydro and then carbon. Hydro, the element that starts with hydro is hydrogen, obviously, and then we have carbon attached. So a compound containing only hydrogen and carbon as its constituent. The word only is very necessary when we are defining this in an exam. Okay, so be sure to take note of the only over here. Now an arene. An arene is a name given to an aromatic compound. So like the benzene I gave for earlier is an arene. Okay, so yeah, that's an arene. Now functional groups. Now these are groups of atoms bonded together, and then these groups of atoms gives an organic compound its unique chemical properties. Okay, so like there is that class of carbon that maybe if it reacts with halogens it will do this, and then once it begins to do that, you know this compound must contain this specific functional group, because it's only that functional group that behaves that way. Okay, so based on the functional groups, compounds tends to behave differently. Okay, now for example, an alkane is not a functional group because it is almost found in all compounds, because you have carbon single bond in almost all compounds, you find them. Now functional group starts from alkenes. So we have some functional groups, they include the alkenes. We have the alkenes, which involves carbon-carbon double bond. Then we have the alkynes, which are what? Carbons triple bond carbon. Then we have the alcohols, or the alkanols. Okay, I prefer you go with alkanol. That is more of like the IUPAC name, so go with that to avoid your teacher giving you maybe wrong for writing alcohol instead of alkanols. So they bear OH group. And then we have the alkanoic acid. Those alkanoic acid, they have the functional group of C double bond O, C single bond O, then an H, or C O O H. So this is an alkanoic acid. They are weak organic acids. Alkanoic acids. So these are some examples of functional groups that we have in organic chemistry. Now let's have a look at how to name organic compounds. These alkanes, alkynes. Let's just do a brief naming of them. So naming organic compounds. Now, depending on the functional group of the compound, the name of the compound differs. Now, there is something very similar, something very similar to all the namings. Okay, so this means when we have a carbon atom, okay, or a compound with one carbon, okay, so let's say one carbon, okay, we have a prefix called mate. The mate is the beginning of the name of that compound. So two carbons, we have what? It. Now when we have three carbons, so the compound contains three carbons, we have what? Prop. Okay, so 4 carbons, we have what? But. 5 carbons, then we have what? Pent. 6 carbons, we have what? Hex. 7, we have hept. 8, we have oct. 9, we have what? Non. And then 10, we have dec. Now remember I made mention of the fact that we have like groups of compounds like alkanes, alkynes, alcohols or alkanols, and then the alkanoic acid. What am I writing? The alkanoic acids. Okay, now I said these ones, they have carbon single bond, this one carbon double bonds, this one carbon triple bond, these ones have OH, and then these ones have COOH. Okay, so now let's take these ones, for example, the alkanes. So an alkane with one carbon, okay, carbon forms 4 bonds. So an alkane with one carbon will be like this, CH4. So this is the structure. So an alkane with one carbon is CH4. Okay, and then looking at this shape per the hybridization, because it has 4 bonds, we can say this is what? Tetrahedral with a bond angle of 109.5 degrees. Okay, so this is tetrahedral, which means the carbon over here is what? sp3 hybridized. We will be looking at this into much depth when we treat alkanes as a major topic or a major tutorial. So yes, so an alkane with one carbon, this is how it looks like. And then when we want to name that compound, we just take the ending over here, the ANE, and then we add it to what we have over here. Sorry, so an alkane with one carbon will be called what? Mate. The prefix is mate, and then we just, because it's an alkane, we add ANE. So an alkane with one carbon is called methane. So the name continues like that. So an alkane with 2 carbons, okay, two carbons will be like this. You just have to make sure the bond around each carbon for an alkane is 4. So in this example we have 1 2 3 4 for this carbon, then 1 2 3 4 for this carbon as well. Okay, so the prefix is what? It. And what it is? What? An alkane. There's no double bond anywhere, so it's an alkane. So we add A and E. So this is what? Ethane. This is what? Methane. The condensed form of this will be what? How many carbons do we have here? We have 2, so C2. Then how many hydrogens? H6. Okay, so you can see this and this, they are increasing by CH2. Okay, so they are increasing by CH2. So the next one in the line will be what? C3H8. Okay, so this is an alkane having 3 carbons, and 3 carbons is prop, so the name will be what? Propane. So the same way, an alkane with 4 carbons will be butane, 5 carbons will be pentane, 6 will be hexane, 7 will be heptane, 8 will be octane, 9 nonane, and 10 decane. Alright, so let's have a look at the naming of the alkenes, the ones with the double bond. Okay, now for the ones with the double bond, sorry, it so happens that there is no alkane that has just 1 carbon. For it to have a double bond, it has to be between 2 carbons, so it starts with 2. So we don't have methane. There's no methane nowhere in this world. Well, if there is any, then we just have to discover it. So an alkane with 2 carbons will be like this. So we have an H here, H here, H here, and then an H here. You can see because it's an alkane, we have double bond. So because it's a double bond, it's an alkane. Okay, so we have 2 carbons, so the prefix is what? It. So we write the it. It's an alkane, there's a double bond, so we add E and E. So this is what? Ethene. So the formula for this is what? How many carbons? C2. How many hydrogens? 4. H4. So C2H4 is called ethene. Now 3 carbons will be what? Propene. So that one we have carbon, double bond, carbon, then another carbon. Mind you, don't have to write another double bond over here, it's just one double bond. Okay, we are going to look at how to name the ones that are having 2 or multiple double bonds within them later. So we have this, then this, then we have 1 2 and 3. Mind the way I'm writing this carbon is having 4 bonds, so 1 2 3 4. The one at the middle over here is having 1 2 3, so we just need to add 1 more hydrogen. The one over here is having 1 2 3 4. Okay, so this is what's called propane. Now for carbon greater than 3, that is carbon is equal to 4 plus, you need to state the position of the double bond in the compound. For instance, let me use this. So so assuming I have another carbon over here, then we have this. Okay, so the name will no longer be propene. Alright, so if this is the case that we have, there are 2 possibilities. The double bond can either be here or can be in the middle or can be here. Okay, so in this case the double bond is over here, so we name the carbons to favor where the double bond is closest. Okay, so by that I mean let's look at that into details when we are doing the proper naming. So here we have carbon 1, carbon 2, carbon 3, carbon 4. Okay, so over here the double bond is on carbon 1. Okay, so when we are going to name this, yes, we have 1 2 3 4, so we have what? But. Okay, so and we have double bond, so it's what? Butane. But where is the double bond on the butane? Because if I say butane, someone can draw it with the double bond over here. Okay, or double bond over here. Okay, so we need to specify that it's on carbon 1, so we write 1 butane. Okay, assuming the double bond is not here and it is over here. Okay, so this one, the double bond is not there and it's on the middle one over here, so the name will cease to be 1-butene and then it will turn to what? 2-butene. Okay, now I know if you are new here, someone is asking, assuming the double bond is not here and it is over here, how will you name it? Well, when the double bond is over here, you can see if you name the carbon from here, then this will be like 4-butene, and it doesn't work like that. Okay, you need to make sure that where you are counting from, the double bond has the least number as much as possible. Okay, so if you are counting from this side, it will be 4, but if you are counting in the other direction, it will be what? 1. So here will be 1 instead of 4. Okay, so in case the double bond is over here, we will still have 1-butene and not 4-butene. Okay, so that is how we name alkenes. So for an alkene with 5 carbons, you just have to note where the position of the double bond is, and then you include that in the naming. So maybe 3-pentene or 2-pentene, something like that. Okay, so let's try and name some few alkynes, and then we end it here and continue with these groups later on in another video. So an alkyne, as the alkenes also, they also start with 2 carbons. So we have 2 carbons triply bonded to each other, then we have 1 hydrogen, another hydrogen here. So the condensed formula is what? C2H2. So because we have 2 carbons, it is what? 8, and then due to the presence of the triple bond over here, so it's an alkyne, so we add the Y and E, so this is ethyne. So if we have 3, so we have this, then we have 1 here, another 1 here, nope, nope, this is already 1, 2, 3, 4, so we don't add any hydrogen to this carbon, so we add 3 to this one. Okay, so the formula is what? C3H what? 1, 2, 3, 4. Let's see whether the number of hydrogens are up to. So we have 1, 2, 3, 4, so 4 bonds over here. 1, 2, 3, 4, so 4 bonds for this carbon. Then 1, 2, 3, 4, 4 bonds. Okay, so this is 3 carbons. We have 3 double bond. We have a double bond over here, triple bond, sorry. So this is what? Propine. Okay, how you call it is propine. Okay, just make sure when you are writing, you write Y and it's not E, because it's triple bond and not a double bond. Now the same way, if we have like 4 carbons and above, we need to state the position of the triple bond as in that of the alkenes. Okay, so this is a general overview of what organic chemistry is all about. We will be looking into much detail what alkenes are, alkenes, alkynes, alcohol, alkanoic acids, and their various reactions. And then yeah, then we name even much more complicated compounds, and we learn what substituent is and how to name a compound, an organic compound containing substituent and all that. So thank you guys very much for watching.